Okay, onward. We're almost to the end of chapter 7. So here we go. This would be section 7.6. This is called solving exponential equations with the same base. And if you like the last section, I think you might like this one because it's basically, once you understand the process, you can do it. And this whole section is dependent on this one fact that I'm going to write. It is a fact. Doesn't really matter which variables I use, but I'm going to just use these. If b to the p is equal to b to the q, B really helping you to really see that we have the same base, then it is a fact that P has to be equal to Q. There is no way we can have the same base and not have the same exponents. For instance, if you just put some numbers in, if you had 2 to the third power equals 2 to the what power, hopefully you see these are the same base. The only way there can be an equal sign here is there has to be a 3 there. So in solving equations, if we just get ourselves in a situation where we have the same base, then all we have to do is set the exponents equal. So some situations we get nice easy problems and we just can straight up set our exponents equal. Other times we have to do a little bit of work. So let's do couple examples. So here we go. Example 1. Given 3 to the x equals 3 to the 2x minus 2. If you are asked to solve for x, this one you should be happy about because you'll notice it's served up with the same base. So the only way that equal sign has any right of being there is that this guy here has to be equal to this guy here. The exponents have got to be equal. So now you just have a little mini problem to solve, and I'll just go ahead and do my little solving this. So I get negative x is equal to negative 2, and when I divide both sides by a negative 1, I get x is equal to 2. And let me just go ahead and check that to see if that's true. So this 3 to the second power equal to 3 to the 2 times 2 minus 2 power. And I think you could probably see already, 3 squared definitely is equal to 2 times 2 is 4, 4 minus 2 is 2, 3 squared definitely equals 3 squared. So that was kind of the easiest one of these types of problems you're going to see. So we'll crank it up a notch. So here is example 2. So given something like this, 2 to the 2x is equal to 8. So you need to recognize that we do not have powers of the same base. So this is a 2, this is an 8. So what we'd want to do in this situation is say, well, is there some way we could have the same base? And so you always want to look towards the smaller base. If you're lucky, somehow you can actually get this guy to write an 8 with a base of 2. And so I'm going to do that. I'm going to say to myself, well, what exponent could I put above a 2 that produces an 8? And 2 to the third power gets the job done because 2 times 2 is 4 times 2 is 8. And so now I can just bring this down, 2 equals 2 to the 2x, and now I have my same bases, and all I have to do is set my exponents equal. So 2x is equal to 3, divide both sides by 2, and in this case x is equal to 3/2. And I think if you come back up here to check this, you'll see that to be the case, because if I take 2 to the 2 times 3/2 and I ask does that equal 8, well, 2 over 1 times 3 over 2, these guys cancel, so I get 2/3 to the third power. Does that equal 8? And sure enough, 8 does equal 8. Okay, example 3. Given 5 to the x minus 1 equal to 0.04. So this one definitely has a different appearance because we do not have the same base, but this is a decimal, so it might be at first you might say, well, I don't think I can make that happen. So I would suggest if you're given a problem like this, where you're given a decimal, and now this requires you to understand your place values. This is in the tenths, this is in the hundredths. You might just take a minute and rewrite it as a fraction. So 0.04 is the same as 4 over 100. Now if I reduce this, 4 goes into 4 once, 4 goes into 100 25 times. Then I want to start thinking about this 25 and this 5, and I might say, well, wait a minute. 25 is the same as 5 squared. But if I were to bring that over, that 1 over 5 squared, that's not going to work because I need the base to be 5. So this is where your understanding of exponents comes into play. Because normally you're not going to think like this, but I need this 5 to be in the numerator. So I am going to ship that up. And by shipping that up, that 5 squared in the denominator becomes 5 to the negative 2 in the numerator. And now I can come over here and plop this guy down, and I got myself a situation where I have my base is the same, and I can set my exponents equal. And so then x is going to be equal to negative 2 plus 1, which is negative 1. Okay, a couple more examples. Example 4. Given 4 to the a equal 8 to the a plus 1. So hopefully you obviously recognize the bases are not the same, so don't let your brain ever think you can do something with bases that are not the same. So my advice I'd given you earlier was look at the smaller number and try to use that as your base. Now your brain, if it's trying to trick you, might try to make you think, oh, I'll put a 4 with a 2 over it. But I just want to remind you that a 4 with a 2 over it is not 8, that's equal to 16. So that's a no-go. So there are situations, and this is one of them, where the common base has got to be a different number. And so you're going to have to more than likely look lower. And so if you think about it, 4 can be rewritten as 2 squared, and 8 can be rewritten as 2 cubed. But I can't forget that I do have an exponent up here, and I also have an exponent up here. So this problem is giving me all kinds of opportunities to use all the things I know about exponents. So a power of a power I multiply. And now here's yet another little danger zone. I'm going to take this, the power of a power, and multiply, but I need to distribute my 3. So this is 2 to the 2a is equal to 2 to the 3a plus 3. So a common error would be not to distribute that 3. So now all's well. I have common bases. So all I got to do is set these exponents equal and finish the job by just solving this. So I'll go ahead and do that. And I don't want to know what negative a is, I want to know what positive a is, so I'm going to go ahead and divide that out. And so in this case, a is equal to negative 3. Okay, one more. Solve 3 plus 7 to the x minus 1 equals 10. So solve for x once again. I really kind of want to focus in on where the x is that I'm trying to solve for. So I'm going to do the same thing. I'm going to get that guy all by itself. And maybe that is what I need to do to make this kind of become an easier problem. So just by coincidence, 10 minus 3 is 7. So I can see right now that I've got myself common bases. The one thing I need to remember, of course, is that a 1 goes up here. So now with my common bases, I can set my exponents equal. So x minus 1 equals 1. And you see then that x then is equal to 2. So there you have it, solving exponential equations with same bases. So now you should go to mathexcelforschools.com and see how you can do on the quiz.